Hey, hi kids. Today we're going to be talking about 7 to multiplying powers with the same base. So if you recall, when you talked about bases and exponents, for instance, a, when you see the base a, we're talking about it's on the bottom, okay? So that would be the base. And then say if we said a like that with the three superscripts, you know that that is the exponent, right? That's the exponent. So we would say that that was a cubed. And you know that, but the base and the exponent. So for a non-zero base a and rational exponents, remember rational numbers can be written as fractions. They're not going to be numbers like pi for you right now, just rational exponents. So it could be 1/2, it could be 1.5, it could be 3, it could be -4, okay? So a to the nth power times a to the mth power is equal to a to the n plus m. We actually add those exponents together. So the reason when we do this, we just keep the base and we add the exponents. 2 plus 4, 3 to the 2 plus 4 is then equal to 3 to the 6th power, okay? So we get 3 to the 6th power for an answer. And I'm going to put this right here. Okay, and then I'm going to, underneath it, I'm going to stress something that we can always expand these. You could say 3 times 3 is 3 squared, right? And then you could say 3 times 3 times 3 times 3, that's 3 to the 4th. So when you look at this, it should make sense because you have 6 factors of 3, which is 3 to the 6th, okay? And we'll worry about simplifying that later. So for the next one, where we have x, we would have 5 factors of x and then another 3. So it makes sense that we would answer this x to the 5 plus 3 power, otherwise known as x to the 8th power. Okay, so we're going to be using this rule for all the problems in this lesson today. Okay, so here we go. The first one, we have m cubed times m to the 4th. Okay, so this is then, and what I'm going to do is I'm going to do all of the evens here. I'm going to take my pen down to 4 here. Okay, so we keep the base. I'm going to use blue. So we have m to the 3 plus 4 power, which is equal to m to the 7th power. And there you have it. Okay, and that's it. We have m is the same base in both powers, so we can just add the exponents when we're multiplying. So now the 5 is not, the 5, I'm going to do the odds, and I'm going to pause, and I'm going to let you do the evens, and I'll go back and fill them in. So for number 3, you have 4t to the -5th power, right? So the 4 is separate from the -5th power there. So we're going to take these, and we're going to reorder them. We're going to say 4 times 2 times t to the -5th times t to the -3rd. Now, one of the reasons why I have students do this is they know that 4 times 2 is equal to 2 times 4 by the commutative property, and 2 times 3 is equal to 3 times 2. Same thing. So when we change the order, what we do is it helps our brain kind of catch up with what's going on, and we multiply regular numbers. We get 8 times, and then we have t to the -5 times t, I'm just going to add that, plus -3. And so we end up with 8t to the -8. And then what we're going to do is we're going to use our negative rule where you have a to the -n is equal to 1 over a to the n. Okay, so we have then 8 stays in the numerator and then t to the 8th in the denominator. So we take the t to the -8 and we take it into the denominator. Remember that t to the -8 is 1 over t to the 8th. Okay, see if that works for you. All right, let's go to 5. 5, what we're going to do is we're going to take 5, 3, and 3. We're going to move that out front, and then we've got an x to the 5th, y to the 6th, and an x squared. So I'm putting them all in order, and then I noticed that, well, I have 5 times 3 is 15. So since we're all on the iPads right now, I put them in order, but do you see that it would be really easy if you just put the x next to the x squared next to the x to the 5th, and then you tack that y to the 6th on the end. Okay, because multiplication, and that's what this is all commutative. So we have 5 times 3 is 15. 15 times 3 is 45. So we have 45x to the 5 plus 2 times y to the 6th. So then we simplify it completely. We get 45x to the 7th power, and we just tack our y to the 6th on. Okay, and there you have it. There you go. Okay. Now, number 7, we have powers of with a base of x and y like we did in the last one. So we can't mince them. We can't mix them up. So we've got x to the 6th, and I'm going to bring the x to the 4th right next to that. And then I'm going to multiply by y squared. So what I'm going to do is take the first two, and I'm going to say, well, that's going to be x to the 6 plus 4, because they have the same base. And then I'm going to multiply by y squared. That's going to give me x to the 10th times y squared, and we can just leave it like that. So I'm trying to keep my exponents at about the same height here. So we get y squared there. Okay, and there is our answer. Okay, let's go to number 9. Number 9, we have a negative m squared times 4r cubed times 12r to the negative 4 times 5m. So when it's all spread out like that, it's harder to keep track of. So what we do is we kind of switch the order with this. So you see that negative in the front? That's actually a factor of -1 here. So I want you to be aware when you see something like that, try to keep track of it and make it a number since you're going to be multiplying. I'm going to put my 4 in the front, then I'm going to put my 12. So all my regular numbers get pushed up to the front, and I have one more, it's 5. So now I'm going to stay alphabetical m before r. Now remember, my -1 is already up there, so I don't have to worry about that. Now I'm going to put my m's in. I have an m squared, and I have just a regular old m. But instead of just leaving it m, I'm going to put it as m to the 1st. And then I'm going to put my r squared, and my r to the -4th, okay? And now I'm going to multiply my numbers. So if you look at it, they're nice and neat right up front, and then I'll multiply them together, and then I'll multiply the powers together using my addition rule. So I have -1 times 4 times 12 times 5. Well, that's a number, right? I think that's 120 times 2. I think it's 240. So -240. -240, and then we have m to the 2 plus 1, and then we have r to the 3 plus -4, 3 plus -4. So then we have -240, we'll keep that, and then we have m cubed r to the -1st power. So what I'm going to do with this one, I have a negative sign out front. That means this is going to be a negative term, but I've got an r to the -1. I'm going to take that r down. I'm going to put it down here at the bottom as r to the 1st. But now that I know this, instead of taking another line, I think what I'm going to do is just say, okay, that's just going to be r, right? So in the top, I have this 240. And I've got this m cubed, and I moved the r to the -1 down to the denominator as just r to the 1st, which is just r. Okay? All right, good. Now we got a couple more to do. I've got number, I think 11, we'll do 11. So we're going to keep the numerator, and is just 1. And we're only going to work with the base and the exponents. See, we have a base a and their exponents in the denominator, because I get a to the 4 plus -3. So this is kind of a nice and compact form, and it's an easy problem, because all we have to do is say, well, what is a to the 4 plus is a to 4 plus -3 is a to the 1st power. But we don't write it like that. We like it simplified a little. So we just have that form where we just say a to the 1st power is equal to 1 over, just a, right? So that is our answer here, 1 over a. Then for number 13, what we're going to be doing in 13 is we're actually going to be applying the distributive property. So remember that I'm going to use red the first time. So I'm going to multiply this 2a cubed, and I'm going to multiply that by the 3a plus, then I've got this 2a cubed, and we're going to multiply that times the 1. So plus 1. So now we're going to simplify this, and now we've got this 2 times 3 times a cubed times a, and we know that's an a to the first power, plus we have just a 2a cubed times 1, which is the same thing, so we just leave it 2a cubed. So now we get 6a to the 3 plus 1 power. You're probably already miles ahead of me on this, but that's okay. That's good. That's where you want to go. You get 6a to the 4th power plus 2a cubed. Okay, and there you have it. Now we're going to do one more, and then we're going to take a break, and you guys are going to try some on your own in between, and then we'll go back and turn the second video on if you need to review it. So for number 15, we're going to be distributing a negative 4x cubed. So we're first going to distribute it to the 3x cubed, and then we're distributing over subtraction. So now I'm going to distribute to the minus 10x. So that's going to be parentheses, negative 4x cubed, and then that is times 10x. Now I already have the minus sign in the middle in blue, okay? So now we're going to simplify, but I'm going to move things around like I've been doing in other problems. So I have negative 4 times 3. Remember that commutative law in arithmetic, you can change the order of multiplication. So now I've got the first term, now I'm going to get the second term. So I have my negative 4 times 3 and my x cubed times x cubed. Now I have in the second one, I've got this negative 4 times 10 and times x cubed times x. So now let's simplify our expressions. So I get negative 12x to the 3 plus 3 power minus a negative 40x to the 3rd plus 1, because remember this x is an x to the 1st power when I change the orders, okay? The order of the factors. So now what do we have here? We have negative 12 x to the 6th power, and it's going to be minus a negative 40, and it's going to be x to the 4th power. So those are not like terms. They don't have the same variables. So what we're going to do is we're just going to rewrite it as a sum. And you know that when you have minus a negative, then that's going to be negative 12x to the 6th power, and then that's going to be plus 40x to the 4th, okay? And now I have some time for you guys to finish up these, and I'm going to have a submission for you to submit your notes each day then. So, but for right now, I want you to work on all the evens in this section, okay? So I'm going to stop this video right now, and we're going to finish 7.2 after you have a chance to practice with the even numbers, okay? All right, I'll see you in a bit.